Okay, so we're going to just go through the objective questions. I'm going to call on random people to give me the answer. And then after that, we're going to discuss the structured questions. And then after that, I will probably end with the structured questions now. So but most of the essay questions I've already answered. Tinggal the calculation questions, which I think you can do. And just this one question, section C lah. Okay. All right, let's start question number 1 first. So if the area of a master piston and the slave piston are 0.03 meters squared and 0.90 meters squared, what is the mass of object P? So, sorry, 0.03, 0.9. Jericho, can we have the answer for this, please? Have they counted?
B.
Boy or donkey, sorry.
B. 2.4.
Oh, 2.4 times 10 to the power of 2. Okay. The rest of you okay ka? Can Okay, did you use 9.81 or did you use 10?
9.81.
You used 9.81 so you definitely got 2.4 Okay. All right, if that's the case, then I won't go into this lah. Okay. All right. Diagram A shows a hydraulic brake system. A driver steps on the brake pedal. Which is the correct relationship? Can I have Iqbal for this? Shafiq, what's the answer for number 2?
A.
Pressure on P is less than pressure on Q. What do the rest think? Do you think Iqbal's answer is correct? Sorry, let's ask the rest of the judges. Okay, I see some judges shaking their head. So, what do the other judges think? Is it A? If it's not A, then what do you think the answer is?
Boy.
Okay, the answer will be B. Sebab Iqbal, this is correct if the word here is force. Then that's correct. Okay, if the force on P is less than the force on Q, I'm so sorry for the noise out there. Okay, but just deal with it lah. So the force on P is less than the force on Q. That is correct because kau tekan sikit saja kan, walaupun kau tekan brake pedal dengan sekuat hati kan, that force is not as much as the force that the car tire is going to experience. Biarlah kalau saya menguji kesabaran saya. Okay, so force on P is smaller than force on Q is correct. But in terms of the pressure, remember this Pascal's principle. Pascal's principle states that pressure is equally transmitted throughout. Okay, so the answer will be B. All right, number 3, diagram 11 shows this one. What is the principle used? You know what? I'm not going to waste time calling people. This will obviously be Pascal's principle. This one doesn't apply over here because this is not a moving situation. It's just mengangkat saja. Conservation of momentum doesn't happen because conservation of momentum happens during a collision. Okay, bila dua berlanggar, okay, when two things collide, then you are talking about conservation of momentum. Collision, rocket, airplane, okay, all this is conservation of momentum. Bernoulli's principle, you haven't learned yet. It's the last subtopic in our chapter. Okay, so yeah. Okay, number 4. Diagram 12 shows the cross-sectional area of a hydraulic jet. The weight of the car is 2.0 times 10 to the power of 6 kg. Hold on. Weight of the car is 2.0 times 10 to the power of 6 kg. Kg. Okay, fine. Let's just use that. The ratio between the surface areas is 1 to 15. So the master piston is 1 and this one is 15. What is the force exerted on the master piston? Oh, okay, interesting. Sorry, Brendan, can we have this answer? Have you answered this?
Is it
So it's Brendan here. A. Sorry, did you say A?
Yeah, if the weight is 2.8 times 10 to the power 6, actually the answer is A.
Okay. Sorry, sorry, it's so noisy. I cannot hear what you say. Oh, it's so embarrassing. Sorry, Brendan, what did you say? Can somebody like repeat to me what Brendan said?
So can the question set the weight done as the unit is kg. Then
Yeah.
2.0 times 10 to the power 6 is actually the weight. Then
Kan?
my answer is 1.3 times 10 to the power 6.
So that means you are saying that this kg should be Newton lah instead of kg.
Yeah, because they mentioned
Okay.
weight. And
So how do you get 1.3? That means you are saying that, okay, 2.0 times 10 to the power 6 over 15 equals to F over 1. Is that what you're saying? So is the answer A? It is? Sorry, I don't have the calculator. 20,000 divided by 2 or 2 divided by 15. Okay. 1, 3, 3, 1, 2, 3, 4, 5, 6. Okay. All right. 1.3 times 10 to the power 6. Yeah, I think this makes more sense now. Because even if, let's say we convert this in kg to Newton now. So 2 times 10 to the power 6 times 9.81 will give us 1962000 Newton. That makes even less sense. Divided by 15 will be 1308000. 1, 2, 3, 4, 5, 6. Oh, same lah. You still get around the same answer lah. My word. Okay. But okay, I think that's fine. We still use Pascal's principle for this. Okay. And we will get the answer lah. A. Okay, number 5. Diagram 7 shows the force F1 exerted on a small piston producing pressure P. Pressure P1 is transferred to the large piston to produce pressure P0. Okay, so which comparison is correct? Eliska?
C.
C, yeah? Okay, all right, good. Pressure 1 is equals to pressure 2. This is obviously wrong. The force cannot be the same and the pressure cannot be unequal. This is actually almost correct, except that it should be F2 is bigger than F1. Okay, because remember, the larger area will produce a larger force on condition that the pressure is the same. Okay, diagram number 6, question number 6, diagram 12 shows force F acting on the piston in a hydraulic system. Which modification can increase the force acting on piston Q? Is Rania here? Can we have Rania for this?
I think it's C.
Okay, C, increase the surface area of piston Q. Yeah, this is correct lah. Because the bigger the surface area, bigger the force. Sorry, Isabella. Okay. Number 7, diagram 10 shows a hydraulic jet. Which modification will increase the pressure, okay, in piston Q? How do you increase the pressure in piston Q? Ooh, interesting. Okay. Let me see. Is Angeline here? Oh no, Angeline is not here. Okay, can we have Louis for this? Louis, what do you think?
A.
Sorry?
I think it's A.
A, decrease the height H.
Wait. No. Wait.
Are you hesitating because of the tone of my voice?
C. C.
C. Decrease the cross-section area. Decrease the cross-section area of P. Yeah, okay, that's the answer. Okay, yeah, this is the answer. When you decrease the cross-section area of P, okay, so P equals to F over A. Yeah? When the cross-sectional area decreases, the pressure over here, the pressure on this piston will increase. And because the pressure on piston P increase, therefore the pressure on piston Q will increase. Okay, so this relationship, we not only just have to think about Pascal's principle, but we also have to take into consideration the original pressure formula, force over an area. Okay, so if we want to increase the pressure here, we have to either increase the force or we decrease the surface area. Okay, all right. Number 8, diagram 7 shows a hydraulic jet used to raise a car to a certain height. Which statement explains the working principle of the hydraulic jet? Can I have Lester for this?
I found this on the web.
C.
C, yeah. Okay, pressure is transmitted equally in the fluid. All right, very good. Okay, let's go to the structured questions. Diagram 7.1 shows a hydraulic system. A force F is exerted, yada yada. The principle involved is Pascal's principle. Okay, compare the pressure at point P and point Q. Miss Tian, can you answer this, please?
Equal.
Okay, so short answer will be equal, but I would always like you to write in full sentence, especially during exams. Now, because we're just doing latihan kan, so no problem. But a sample answer will be the pressure at point P is equal to the pressure at point Q. Okay, I would always recommend everybody to answer in full sentence. Okay, when we do exercise like this and you just write equal, okay, no problem. All right, B, diagram 7.2 shows a hydraulic jet. In a car service center. Okay, so in the car service center, you have a load over here, and this is the handle, yada yada. So a force 50 Newton is exerted on the small piston when the handle is pushed down. Okay, so handle pushed down is 50 Newtons. Cross-sectional area of the small piston is 0.04 and the large piston over here is 0.8. Okay, calculate the pressure exerted on the oil in the hydraulic jet. Okay, this one, pressure exerted on the oil, are we talking about input pressure or output pressure? Shin. When they say pressure exerted on the oil in the hydraulic jet, right, are we talking about input pressure, the one that you push, or the output pressure? Which one are we talking about? Which one is this question referring to? Okay, we're talking about input pressure. Can you tell me what is the value of the input pressure? Sorry, still Shim.
Is it 50 divide 0.04?
Okay, which is?
1250
Okay, 1250 unit is?
Pascal.
Okay. So then we use that to calculate the force, okay, that is exerted on the large piston, because we know that in Pascal's principle, input pressure equals to output pressure. So we will have 1250 equals to the force that we want to count over what is the large piston's area, 0.8. Okay. And so what will my answer for the force be? Sorry, anybody lah. This is a simple calculation. Let's not waste time.
1000 Newton.
Okay, 1000 newtons. So you notice that 50 newtons, okay, 50 newtons, dia letak 50 newtons, which is about 5 kg, 5 kg worth of force. And you get an output force of 1000 newtons, which is about 100 kg worth of force. Okay, I'm just going to add one small question now. Can you tell me what is the magnification? What is the force magnification? What is the value of the force magnification?
20.
How do I count 20?
0.8 over 0.04.
Okay, very good. 0.8 over 0.04, you just get 20 times. So dia 20 kali ganda, and it's true lah, 50 times 20 will give you 1000. Okay, so the magnification is a very important thing to understand, because the magnification shows us that the relationship between the force and the area is directly proportional. The bigger the area, the bigger the force. Okay, so the magnification proves that. Okay, based on diagram 7.2, explain how the handle is used to lift the load to its maximum height. Now this one I've already covered in this part. Okay, what happens when the handle is this. But basically, okay, so when we push the handle down, okay, take a look. When we push the handle down, this one will be closed, and no, hold on. Yeah, correct. When we push the handle down, vent A will be closed, and vent B, valve B, astaga, sorry. Okay, when we push the handle down, A will close and B will open. Okay, and so the oil will push the large piston. Then when we pull up the handle, bila kita tarik ke atas, it will be the opposite lah. B will close, okay, and A will open. And what happens is the oil reservoir, the oil will flow into the small piston. Okay, exactly the same as the one at the beginning. That we did yesterday lah. Okay, and it's basically the same. When we push down, okay, then you see actually the load goes up. But when we tarik ke atas, you don't see the load coming back down, right? Imagine if you push down, it goes up, then you pull up, it goes down. Then what's the point of doing this? Okay? So that's why the valves exist. So that when you push down, okay, the oil is used to push the piston. But when you pull up, the oil will flow back into the small piston. Okay, and valve B will close now. Okay, that's a very important thing to talk about. Okay, explain one modification to the large piston that enables the jack to lift a heavier load. What should we change about a large piston, okay, in order to be able to make it to lift a heavier load? Sorry, can I have Wilson for this?
Surface.
What do I do? Sorry?
First area.
Okay, increase the surface area of the large piston. But the only thing is, this is a 2-mark question. So you not only have to tell me the modification, you also have to explain why. Okay, why, Wilson? What happens if we increase the surface area? What happens when we increase the surface area? Everybody's like shouting the answer to their muted mics, Wilson. Everybody's like.
The first increase.
Okay, so it will produce a larger force. Yeah, sorry, because I'm seeing the camera. Everybody's like, they're shouting their answers to the muted mics. Okay, so guys, since we are talking about exercise questions and exam, it's important to note this. You need to look at the number of marks that is allocated for a certain question. If there are 2 marks, then you have to think about it. Okay, it means I have to give one suggestion and I have to explain the suggestion. Because the question also asks you to explain. Okay, if it is just 1 mark, the question won't say explain. The question will probably say state one modification. Then it will probably be only 1 mark. So all these things are all what we call answering techniques, how to answer exam questions. But if anything, okay, let the number of marks guide you, okay, on how many points you need to make. Okay, and don't be satisfied until you have at least 2 points in your answer. Kalau kau mau 2 markah, kau mesti nyatakan 2 ayat. Okay, so the first one will be the modification is to increase the surface area of the larger piston. Okay, and the explanation for it will be so that you can produce a larger force. Okay, so I think that's it for today. I've already covered all this yesterday, so it's a very this one. So today, so yesterday I said that this is your homework, right? This thing is your homework. Okay, I just want to add one more for today, which is this question. Okay, I've talked about this so many times. Sorry, I've talked about all these modifications so many times that I think you don't really need me to go through it again, but you need to answer it yourself. So this one, please answer in table format, just like our normal section C lah. Okay, table format only got two. What is this? Oh, sorry. So the left side will be suggestion, and then the right side will be explanation. Okay, so you just follow lah. Since there are 10 marks, you need to give me at least 5 suggestions and 5 explanations. Okay, that means each suggestion, 1 explanation. Okay, so let's take a look. Type of brake fluid is 1. Okay, it's the first one. The second one is the characteristics of the brake fluid. Okay, the third one, so this is TE, this is TE. The third one is the size of the master piston, T-san. And then slave piston is the fourth one. And then last one is the material used for the fluid transmission, pipe. Okay, correct, Michelle, pipe. Okay, let's not make that mistake that I made yesterday. Pipe. Okay, so this is the TO. Okay, actually, if you had followed our class yesterday, you actually can kind of see all the answers all over this section B part. We discussed this yesterday. So all you have to do is just recreate the answers and put it into this table format. Okay, so yesterday the question, yesterday the question, which is, where is this question? Okay, which is this question, the explanation on the hydraulic lift, A and B, guys, okay? A and B, together with this question, okay? Please write it all down in one full scap paper and hand it in by the 5th of April. Okay, it's a very long time just to do 2 simple questions. Okay, just hand it in Google Classroom by 5th of April. Those of you who haven't finished the siphon experiment video, okay, please also do it by the 5th of April. And those of you who still haven't done the first video for the flip grid, please also do it by the 5th of April. Otherwise, we will have to use different ways, okay, for you to do this explanation.